दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. We have discussed oxidation, reduction, oxidation number, oxidizing agent and reducing agent. Now we'll come to what are redox reactions and how to balance the redox reactions by ion electron method. So a redox reaction is a very important reaction which comes in many chemical reactions. So coming to this, what is a redox reaction? What is this a redox reaction? So those reactions in which the oxidation and reduction take place simultaneously are called as redox reactions. Those reactions in which oxidation and reduction take place simultaneously are called as redox reactions. So we'll say those reactions in which oxidation and reduction takes place simultaneously. Are called as redox reactions. Those reactions in which oxidation and reduction take place simultaneously means oxidation is taking place, so also the reduction is taking place. Now what is oxidation? Oxidation is any one of the process: addition of oxygen, removal of hydrogen, increase of positive valency, decrease of negative valency, or increase of electronegative element or loss of electron. What is reduction? The reverse process. The removal of oxygen, addition of hydrogen, decrease of positive valency, increase of negative valency, removal of electronegative element, or the process which involves addition of electron. So if both are taking place, we call these reactions are called as redox reactions. So then we'll take an example. So in these redox reactions, oxidation and reduction take place simultaneously. So then comes, what is this oxidation? So if you come to an oxidation reaction, reduction is also going on. In reduction reaction, oxidation is going on. Why? What is oxidation is brought out, oxidation is carried out by whom? By the oxidizing agent. Oxidizing agent is one which brings out oxidation and gets reduced during the process. Oxidizing agent is one which brings out oxidation and gets reduced during the process. That means what? Oxidation is taking place, oxidizing agent carries out oxidation, but what happens to it? It undergoes reduction. So where there is oxidation, there is reduction. So if you come to reduction, reducing agent is one which brings out the reduction and gets oxidized during the process. So during reduction, the reducing agent reduces, and what happens to it? It gets oxidized. So where there is reduction, there is oxidation. Hence oxidation and reduction take place simultaneously, and these reactions are called as redox reactions. If you think of an oxidation reaction and there is a reduction reaction, In both reactions, they are oxidation and reduction taking place simultaneously. Now we'll just saw the question may be there for a student of +2 first year science, that justify oxidation reduction take place simultaneously. Instead of what is redox reaction, the question they may ask you that justify oxidation reduction take place simultaneously. So we'll say that oxidizing agent is one. Oxidizing agent is one which brings out oxidation, and gets reduced during the process. So what happens? Hence, during oxidation, reduction of oxidizing agent takes place. So oxidation and reduction take place simultaneously. Oxidation and reduction take place simultaneously. So if there is oxidation is going on, then reduction is also going on. So oxidizing agent is one which brings out oxidation and gets reduced during the process. Hence, during oxidation, reduction of oxidizing agent take place. So oxidation and reduction take place simultaneously. So we'll take an example like this. So if you take an example, suppose we take sulfur dioxide oxidizes hydrogen sulfide to form sulfur and water. So we have 2 oxygen, we multiply this by 2 water. We have 4 hydrogen, we multiply this by 2, and we have 3 sulfur, this. So sulfur dioxide is the oxidizing agent. It brings out oxidation of hydrogen sulfide to sulfur. Sulfur dioxide oxidizes H2S to sulfur. So here oxidation number of sulfur is -2 and sulfur is 0. So this reaction is oxidation. Then what is happening? In sulfur dioxide, oxidation number of sulfur is +4 and sulfur is becoming 0. So this reaction is a decrease of oxidation number. So this reaction is a reduction reaction. So sulfur dioxide is oxidizing H2S to sulfur and gets reduced to sulfur. So oxidation and reduction taking place. So this is an example of redox reaction. During oxidation, reduction also takes place. So what is H2S? Here H2S is the reducing agent. So H2S reduces sulfur dioxide to sulfur and gets oxidized to sulfur. So we can say here sulfur dioxide oxidizes H2S to sulfur. How we know? Oxidation number of sulfur in H2S is -2 and it is becoming 0. Increase of oxidation number is called oxidation. So this reaction is oxidation. But what has happened? The hydrogen sulfide reduces SO2 to sulfur. SO2 to sulfur. Why? Now sulfur, in sulfur dioxide, oxidation number of sulfur is +4 and it is becoming sulfur. So during oxidation, reduction take place, and during reduction, oxidation take place, and this is an example of oxidation-redox process. So where there is oxidation, there is reduction. Where there is oxidation, there is reduction. And so these reactions are called as redox reactions. Now we'll come to this. Another example we will take. Suppose we take ferric chloride, and we add stannous chloride to that. So this stannous chloride is Ra, I am writing, is a reducing agent. So this stannous will reduce ferric chloride to ferrous chloride and is getting oxidized to stennic chloride. So if we balance here, so uneven chlorine are here, so we'll multiply this by 2 and multiply this by, this will become 6, this will become 3. So you get 6 and this becomes 6. So 6, 8, and we'll take ferric chloride is forming stannous chloride. So this is a stannous, oxidation number of stannous is +2 and oxidation number of stennic is +4. So this from stannous chloride to stennic chloride, this reaction is oxidation. And ferric chloride to ferrous chloride, this reaction is reduction. So what is happening? Stannous, so here oxidation number of iron is +3 and here oxidation number of iron is +2. So stannous chloride is reducing ferric chloride to ferrous chloride, and stannous chloride is getting oxidized to stennic chloride. So this is ferric chloride acts as a here oxidizing agent, and the stannous chloride acts as a reducing agent. So we get ferrous chloride and stennic chloride. They have ferric chloride, ferrous chloride, ferric chloride to ferrous chloride. So this ferric chloride is reduced by whom? Stannous chloride to ferrous chloride. So this reaction is a reduction reaction. This is what reaction it is? It is a reduction reaction. So what happens to stannous chloride? So stannous chloride is getting oxidized to stennic chloride. So this reaction is reduction, oxidation. This reaction is oxidation. So we say oxidizing agent is one which brings out oxidation and gets reduced during the process. Hence during oxidation, reduction also takes place. Reducing agent is one. What is this? Stannous chloride. Reducing agent is one which brings out reduction and gets oxidized during the process. Hence during reduction, oxidation also takes place. So every reduction reaction is supported by an oxidation, and every oxidation reaction is supported by a reduction. So where there is oxidation, there is a reduction. Hence oxidation and reduction take place simultaneously. Now we will come to reactions, oxidation reduction reactions. So these reactions are generally balanced by partial equation method, and they are also balanced by ion electron method. We have learnt already how to balance equations by partial equation method. Now, with that knowledge, partial equation method, we will now come to balancing equations by ion electron method. So this generally all the redox reactions, they are balanced by ion electron method. So why this question? My question is this: why we will trying to balance this ion electron method, balancing equations, redox reactions by ion electron method? Now, why at all this is attempted, balancing equations by ion electron method? My question comes, why this is done? Now, what is oxidation? So what is oxidation? Loss of electrons. Suppose M is an element, it is undergoing oxidation to form M plus, and electron comes. So this reaction is a oxidation reaction. So what is happening? During oxidation, there is an increase of a charge, positive charge, ionic charge is increasing, and electron is lost. Electron is lost. Then what is reduction? Suppose you have X and we are adding electron, and this forms X minus and X minus. This forms X minus. So this reaction is reduction. Reduction. So what is happening here? So we have, it is balanced. How? Positive, negative. Here this side is negative, this side is negative, balanced. So what is happening? During oxidation, electron is lost. During reduction, electron is added. So oxidizing agent is one which accepts electron, which gives the electron. Oxidizing agent brings out oxidation. Who will bring this oxidizing agent? Will bring out the oxidation. So this oxidizing agent will take the electron. So oxidizing agent brings out oxidation. So during oxidation, what happens? The electron. Who will take the electron? Oxidizing agent will accept the electron. Then during reduction, this is done by whom? By the reducing agent. So reducing agent will give the electron. So in a chemical equation, what happens? When the oxidizing agent will react with the reducing agent, when these two will react, they will balance each other. Why they will balance each other? Now, because substances when react, they react by their equivalence. They don't react by number of atoms. They react by their equivalences. Substances when react, they react by their equivalence. One equivalent of one is equivalent to one equivalent of the other. So they will undergo chemical reaction in equivalent amount. Hence, the number of charges increased during oxidation will be balanced by the number of charges decreased during reduction. And number of electrons lost during oxidation will be equal to number of electrons gained during reduction. Hence, it is very easy to balance a redox reaction by ion electron method. So all redox reactions, we can represent them by their ionic form, and representing the ionic form, we can balance them very easily by balancing the charges, by balancing the electrons. So one simple example, let us start with a very simple example, then we will go to other difficult thing. So we have done one equation here. Ferric chloride is stannous chloride. Stannous chloride reduces ferric chloride. to ferrous chloride and gets oxidized to stannic chloride. So here stannous chloride is a reducing agent and ferric chloride will be an oxidizing agent to stannous chloride. So stannous chloride to stannic chloride is oxidation. So this stannic chloride is the oxidized state. And ferric chloride is forming ferrous chloride. So here charge of ferrous is +2, charge of ferric is +3. So decreasing. So this reaction is a redoxon reaction. Hence ferric chloride is reduced state of ferrous chloride, reduced state of ferric chloride. So this is the reduced state. So we want to balance it by an electron method. So we got the equation. So what we will do? So first represent the oxidized state and reduced state of the substances in their ionic form. So what is happening here? Ferric Fe +3 is forming what? Fe +2. This is one equation, half equation. This oxidizing agent is becoming ferric chloride, is becoming ferrous chloride. And what is happening here? Stannous chloride is forming stannic chloride. So we represented there in their ionic form. Ferric chloride FeCl3. This is FeCl3 and here FeCl2. So ferric chloride, ferric is forming ferrous and stannous is forming stannic. So these we have represented ionic form. Now we have to balance it. So we will have balanced this and we will balance this. So in ferric, this is half equation. This reaction is called half reaction and this reaction is called a half reaction. So stannous chloride is reducing agent. So what we have done? We have written the oxidized and reduced state of the substances in their ionic form. So number of electrons lost by stannous will be equal to number of electrons gained by ferric. So now what will happen here? We will balance this, So ferric is forming ferrous. So we are balancing this. Ferric chloride is reduced by stannous chloride to stannic chloride. So this is a one reaction. Ferric to ferrous, this is one reaction. Stannous to stannic, one reaction. So this is called a half reaction. This is a half reaction. So let us balance this. Fe +3 is forming Fe +2. So there are positive charge. Here is 1. So we will add 1 electron to this to make it equal. Fe +3 plus electron will form Fe +2. So this is now balanced. Now if you come to stannous, is becoming stannic, Sn +4. So how many positive charges left side? 2. How many positive right side? 4. So we'll add 2 electrons this side. So this is oxidation half reaction and this is reduction half reaction. So we wrote the oxidation reaction half reaction and reduction half reaction. So how many electrons are taking place here? 2. But how many electrons are here? 1. So we have to balance the electron. Because we have balance the charges, we have to balance the electrons. So we will multiply by 2. So if we not this, then what will happen? 2 Fe +3 plus Sn +2 is forming 2 Fe +2 plus Sn +4. Why? The electrons will cancel. Why? Now electrons, substances when react by their equivalences. Substance, so 1 electron, here 2 electrons are lost. So here 2 electrons, those 2 electrons will react. So 2 molecules or 2 equivalents of ferric chloride Hence, we now balance this equation. We will multiply this by 2 and we will multiply this by, so this side 2. So 2 FeCl 2, 4, 6 plus 4, 6 plus 2, 8, and that is balanced now. Now you see, very easily from this we could know what to do. So very easily this is balanced. So this is called how to balance and how to represent a redox reaction in ionic form. Now we'll make certain rules, just like as I have told you, SAM is a method for balancing partial equations. Exactly, we will take some principles for balancing these equations by ion electron redox reactions by ion electron method. So we have to first take some rules, and we have to follow those rules, and very simple rules we will follow, and by that we can explain this. So the rules for balancing equations by ion electron method. So what is going on in this reaction? Oxidation is going on and reduction is going on. So what we did, we have to find out the oxidized and reduced state of the substances first. So first is ascertain the oxidized and reduced state of the substances. That means you have to find out. Ascertain means find out. Find out the who is oxidized and who is reduced. Ascertain the oxidized and reduced state of the substances. We found out ferric chloride is reacting with the stannous chloride to form ferrous chloride and stannous chloride. So ferric chloride is forming ferrous chloride and stannous chloride is forming stannous chloride. We balanced ferric chloride, ferrous chloride. We balanced stannous, because who is taking part in chlorine is not getting oxidized or reduced. Who is undergoing oxidation? The ferric is undergoing reduction and stannous is undergoing oxidation. So we will see in the reaction that one whose oxidation number is changing, is undergoing oxidation or a reduction. So we have to find them out. We have to represent them. Second, write the oxidized and reduced state of the substances in their ionic form. In their ionic form. Oxidized state and reduced state, as you have done. Ferric, ferrous, ionic form. So ferric is forming ferrous, stannous is forming stannic. We represented them. Then then we'll go, one reaction is oxidation reaction, the other reaction is redoxation reaction. We will balance the oxidation reaction first separately, and we will balance the redoxation reaction separately. Then we will we have to done what? We will balance the electrons to bring out the reaction. So write the oxidized state and reduced state of the substances in ionic form. So this is called the half reaction. So write the half reactions of oxidation and reduction taking place separately. So these are called what? Half reactions. These reactions called as a half reactions, separately in ionic form. In ionic form. So then what you will do, we will balance the oxidation half reaction and the reduction half reaction and balance the electrons. Why? Oxidation is a process of loss of electron. Reduction is a process of addition of electron. So the number of electrons lost during oxidation will be equal to number of reductions taking place in the reduction. So these electrons are released and those electrons will be used for reduction. So you will balance that. If balance, the equation is balanced. So this oxidation half reaction and reduction there. Then fourth is balance the atoms if necessary other than oxygen and hydrogen. Don't balance oxygen and hydrogen other than balance the atoms if necessary. Balance the atoms of half reactions to get the atomic equation other than oxygen and hydrogen. We will not balance oxygen and hydrogen, we will balance the other reactions. So now we balanced. So then question comes, how to balance oxygen and how to balance the hydrogen. Balance the oxygen atoms by adding water molecules on the other side. If one side, if oxygen is there more and other side oxygen is less, then add water molecule on the other side to balance. So we have balanced the oxygen by adding water molecule, but what we have done? We have increased the hydrogen. So we have to balance the hydrogen. Balance the hydrogen atoms by adding hydrogen ions on the other side. So now hydrogen atoms are balanced, oxygen atoms are balanced. But what has happened? The charge increased. We have taken water molecule, but we balance the hydrogen atoms by what? By adding hydrogen ions. So positive charge is increasing. Now we have to increase the positive charge. Next is what? Balance the charges. Balance the charges by adding electrons. So we have balanced half reaction oxidation, half reaction reduction by this, by balancing the electron charges. Now we got the half reaction of oxidation, we got the half reaction of reduction. Then they will now react in equivalent amounts. So balance the electrons to cancel out the electrons. of number of electrons lost during oxidation will be equal to number of electrons gained during reduction. So we have to do what? Now we have to multiply by desired number to cancel out the electrons, of two half reactions. So the next point we will take this. We got the half reactions. So then comes to cancel out the electrons of half reaction of oxidation and half reaction of reduction multiply with simple integers and add them to cancel out. So cancel out the electrons of half reactions of oxidation. During oxidation electron is lost, and half reaction of reduction, multiply with simple integers and add them to cancel out. So that will complete your reaction. So if all these rules, if I write one simple reaction, let me do one reaction I have written here. I will take a very simple reaction which I have done, and I will apply these rules and balance it. Then we will take different reactions and balance the equations. So let us take a simple reaction. Sulfur dioxide reacting with H2S to form H2O and sulfur. So this is the reaction. So hydrogen sulfide is the reducing agent. It reduces sulfur dioxide. So sulfur dioxide is oxidizing hydrogen sulfide. So this is your oxidizing agent here. And to balance this, we will balance this equation by ion electron method. I am not balancing this. I am not balancing. I have written skeleton equation. So we will write the skeleton equation of oxidized and reduced state of the substances. So sulfur dioxide plus H2S forming H2O plus acetane, the oxidized. That means sulfur dioxide is forming sulfur and hydrogen sulfide is forming sulfur. So SO2 to here sulfur oxidation number is +4, and here oxidation number is 0, and here oxidation number is -2, here oxidation number is 0. So H2S. So this sulfide is becoming sulfur, and this reaction is the oxidation reaction, and sulfur dioxide is forming sulfur. This reaction is reduction reaction. So I will write the half reaction of sulfur dioxide, and I will write the half reaction of H2S. So second step, what will I do? Ascertain the reduced and oxidized state of the substances. Then represent them. Sulfur dioxide is forming what? Sulfur. So this is equation 1, half reaction. What is this reaction? This +4 is becoming 0. So oxidation number is decreasing. So this reaction is a reduction reaction. Reduction half reaction. And the other reaction is what? H2S is forming sulfur. So this is the equation 2. This is the oxidation reaction. Why? Now oxidation number of sulfur is -2, here 0, and here it was -2. So ascertain the oxidized reduced state of the substances and represent the half reactions we represented. Then represent them in ionic form. We will do the first reaction in ionic form. So sulfur dioxide is forming sulfur. We will balance this equation first. Ionic form. So this is our equation 1 in ionic form, and S-2 is forming again sulfur. This is our equation 2. This is the, we have represented them in ionic form. In ionic form, sulfur dioxide. So we will balance this, and we will balance this applying the rules, then add the equation. So what will you do now? We will first balance sulfur dioxide to sulfur. We will now taking sulfur dioxide to sulfur. This equation. So now what is happening here? Here to balance the oxygen atoms by adding water molecules on the other side. So we'll add water molecules, 2 water molecules on the other side. Here you have oxygen. How many oxygen atoms are here? 2. Here no oxygen atom. So we'll add 2 water molecules to balance the oxygen. Then second step what? Balance the hydrogen atoms by adding hydrogen ions on the other side. How many hydrogen atoms are here? 4. And so we will add 4 hydrogen ions this side, 4H plus, to get sulfur plus 2 water. Now hydrogen ions, hydrogen is balanced, sulfur is balanced, oxygen is balanced, hydrogen is balanced. Now who is not balanced? Charge. Balance the charges by adding electrons. So sulfur dioxide 4H plus how many electrons? 4 electrons to form sulfur plus 2 water. 2 water. So one equation is balanced here. 1/2 reaction. So this is what which reaction? Now there is a +4 0. So reduction half reaction balanced. So the other side is what? Sulfide is forming sulfur. So here there is no change of other atoms. So only we will balance the electrons by adding electrons. So -2 will add electrons. So we got this equation now. So this is the redox oxidation reaction, half reaction, and the reduction half reaction. So here 2 electrons are involved, and here 4 electrons are involved. So we'll take them, add them to cancel out the electrons. So we will write here S-2 is forming what? Sulfur plus 2 electrons. So what the rule says? Balance the electrons by multiplying with simple whole numbers. We have 4 electrons, here we have 2 electrons, so we'll multiply the equation by simple whole numbers to cancel out the electrons. So this 4 electron will cancel, so we'll get sulfur dioxide. So 4H plus, then 3S-2 will have 3S. You have sulfur dioxide here. And so S-2 we got S-3, 2S-2. 2S-2 will get 3S plus 2 water. So this is the balanced ionic form, ionic equation. So what was the, so if you compare the equation, so the SO2, H2S forming sulfur plus water. So this is 3S, this is 2S2S. So the same thing, 2S2S, 4H plus. So here you have 4H plus. So you have 2S-2, we have 2S-2. And you have 3S, we have 3S. We have 2 water, and here also we have 2 water. So whatever we do in partial equation, exactly same thing is going on in ionic form. but this is the way it will help us in studying the redox reactions very beautifully, and their chemistry, oxidation, reduction, equivalent mass, etc. we will be doing this. So next class I will be taking reactions involving different redox reactions and balance them in ionic form. Thank you very much.